it by working backwards. So if you think the answer is g of x equals negative x minus 1, here's the original function, right? That's close enough. What do I have to do if it's a minus 1? First thing you do is you shift it which way?
Right.
Right 1. And then that's what you see, because you see it's shifted right 1, but what happens, okay? So it's shifted right 1. Now these both do what? Reflected across the y and then reflected across the x. Doesn't matter the order, does it? So if I reflect it across the x, it looks like that. Well, what happens when I reflect it across the y? Instead of starting at 1, 0, it starts at negative 1, 0. It goes like that. So if you do x minus 1, because I know in your mind you're saying, well, it's shifted 1 to the right. Well, that's where the result ends up. But if you write it like that, okay, if you write it like that and you go through the steps, it ends up here. So here's what you got to do. You actually doesn't actually shift to the right. It actually shifts to the left. Okay, and so then when we reflect it, then we take care of that starting point. So it really shifts here, and then when reflected here, and then what happens when it's reflected across the y-axis? Jumps over here, and then everything flips. Okay. So to actually get it over there with that reflecting across the y-axis, you actually have to shift it the other way. So think about that when you're doing 130. Okay. And that is not just a straight reflection. There is a shift involved across there. Lily.
Why would 129 be the square root of?
Well, you can write it that way, but I'm just the direction. Just say write it in terms of that. So if you put square root, that's fine.
Okay.
You just can't put x squared for 130 because it's technically not a square because it doesn't go all the way.
Okay.
So yes.
I'm gonna throw this out.
Don't give up.
I save all my mental power for physics and running. I need it there.
So you're tapped out in math class.
Yeah, physics just like slaps me first period.
And then you're done. And then you gotta recharge.
Then I gotta recharge for running.
And then you're back to, and after that, everybody else.
Yeah, physics is really easier.
Physics, nobody understands what they're doing.
What's that?
I know everything that's going on right now, Ian.
You guys don't even know anything physics. You guys are in camp, not stupid.
That's what you just do like that.
Oh, you are. I forget you exist. Talk right. Where's that group next to my table?
Yeah.
Can we see you drink through
Where's this point gonna go?
What?
this one?
Can we drink through the
The church one of those times.
Yep.
I mean,
So it would be at 3, 0, and it would be on -2. But it's not there. Move over. You gotta count for the shit.
negative x plus 2. Oh my god.
You probably swallow a real small drink.
Why?
Shocking up in our county.
This is how she does things. So I went to bed.
What county is
I'm not doing
that?
it. I know, I can't do it.
You should've got a present. Just like, how you
It's gotta be no grand.
If I did for now.
She raised me.
I know, she told me that I could do less than
She was racing to the
Yeah. We're not six hours. Yeah, but with the y-axis. She's talking about it.
Alex thinks it's good.
She said district separate.
Alex literally asked me to ask you
That one go to
before he said this, I'm like, You guys don't expand anymore? No, I don't. She's still here.
There's a shift.
If you look at our team for.
Alright, let's see. Ty, is that what we have?
Yeah.
Okay, negative x minus 2. Okay, for that one. Where's the original one start at? Negative 3? Correct? And then this is, what is this point?
Negative 1, negative 2.
Negative 1, negative 2. And is there another point on the other side?
1, 0.
1, 0? Okay. 1, 0. And then what, 3, 4 is up there. If you do a straight reflection across the y-axis, okay, what's that going to look like? This negative 1, negative 2 is going to drop over, move over here. That's going to move over here. That's going to move over here. It's going to look like that. How is that different than the actual g of x on there? The actual g of x on there doesn't start all the way over at 3. Where does it start at? Starts at 1. So that means there's a shift involved. Okay, there's a shift involved. But you have to shift it before you reflect it. So to get it to go to the right spot, you got to shift the original one how far? You got to shift it to the left 2. Okay? Actually, no, you got to shift it to the right 2 so that in the end it will match up. Okay? On that reflection. So if you shift the original one, where's my original one? Okay. If I move this over to here, I move this to here, and I move this to here, it'll look like that. And then what happens on the reflection? That puts it back here, puts that one over there. Okay, that's where you get that. So transformations are hard. I mean, it's hard to keep everything straight. You got to draw things out sometimes, and just take your time on a few of these. We went through that yesterday. Homework-wise, double check your matching ones. Make sure those are okay. The even. And I'll pass out these here in a second. Good? Get through those? All right, now here's the graphs. 77. Now I put the parent function on there. Shifts right 3, vertical compression by 1/2. Okay, shrinks it down. Reflect over the x-axis. Puts it upside down and shift up 2. So you should end up here at least label 3 points. Thomas?
How do you do the vertical compression?
Vertical compression. Wherever the y-coordinate is, if it's being compressed, you're going to cut it, since it's compressed, in half. Okay, you're going to shrink it towards the x-axis. So for this point right here, okay, for that point right here, I'm going to go 1, 2, 3 to the right. Got it? Vertical compression by 1/2. Well, what's the y-coordinate here? It's 4. Shrink it to half the distance to the x-axis, which puts it at 2. Got it? Always that's how you compress it. Reflects over the x-axis to here, and then it goes up to that point. So whenever you compress it, you're basically reducing that in half.
So you're not worrying about the right side on the x-axis?
No, it's not like you would say, I'm going to move it half and half. Like you're just going to, vertical compression is just straight y coordinate. Horizontal compression is straight x coordinate. Okay? Now, if there was both of them, you'd have to move them, but I'd move them one at a time. Okay?
I'm sorry.
No, that's fine. So now the second one here, 79, you got a vertical stretch by 2. So that takes it up to, so if this was at 1, it'll eventually end up at 2. If this was at 2, it goes to 4. But after the shifts, we should have -1, -3, 0, -1, 3, 1, and then 8, 3 for your points. Okay? Be able to label those. It needs to be clear. And then 81, -2, absolute value. So we got a vertical stretch by 2. So if and we got a shift right 1, reflect over the x-axis, and then it goes up 2. So in this case here for this vertical one, let me start with this 0.22. Shift right 1, vertical stretch by 2. So it goes in, so it's at 2, it's going to jump up to 4. Reflect over the x-axis to 1, 2, 3, -4, and then go up 2, and that's where that point ends up. Okay, so vertical stretch, double the y coordinate, double the y coordinate. Other questions on those? 94. Nathan Popio, what do you get for 94?
I got negative absolute value 1/2 x minus 2 absolute value minus 3.
Like that?
Yeah.
Can we call it g of x or f of x?
Sure.
Sure?
Yeah.
All right, we gotta give it a function name. All right, everybody needs a name. Oh, throw the negative on the inside. Throw the negative on the inside because that changes the axis. So the negative's on the inside with the x, that means it's going across the y-axis. Negative on the outside puts it across the x-axis. So just be careful of that. Okay, on that one. Good on the 1/2. That's all. That's a common one that's missed. That means it's a horizontal stretch. Okay, between 0 and 1. It stretches it out. All right, good. Anything else for the good of the old cause? Ty.
They were saying that in the textbook, would they say horizontal stretch of 2, or would they say a stretch of 1/2?
No, it's a horizontal stretch of 2.
Okay.
Okay, if they said a horizontal stretch of 4, then it'd be 1/4. Horizontal stretch of 6, 1/6. Now, if there's a 2 there, that means it's a compression by 1/2. Okay, you gotta watch that. Okay. All right, we did that. Section 2.8. We got 2.8. We're gonna get about 3/4 of the way through that today. Finish it up. We gotta start 2.9 tomorrow and finish it on Friday. And that puts us on target for the test on Wednesday. That work for you?
No, today Wednesday? Okay.
As long as it's
I'm doing
not
it, Adrian.
trash day.
So you literally lost like every single year? I did. T-Rex.
I struggle with this. Do you want to get the money?
Do it this year. I was working on last year.
No, but
I know.
Why?
No, I see Banana.
Banana on it.
Senior.
That's running.
And then when I smash it, and the camera.
That's.
It's way every day.
I
We do the locker room stuff, right? That's so
You should see
easy.
this robot.
Not existent, so you hang out in the hallways by the lockers.
You guys just.
Yeah. No, the elites hang out.
The elites hang out.
So I go to work, but.
Oh, no, the elites hang out.
Is that locker
Wait, what happened?
We have our fake couch that we stole from trash. And we also have only one clean shower that doesn't leak.
All of our class
All right,
First of all,
let's see, Adam.
Yeah.
Do you remember what that means?
What am I supposed to?
All right, maybe not.
It's like the stuff that it makes you not be able to see.
Oh, that's right. So,
There you go.
what's this?
You forgot the L.
It's like-
It's a Jerry ball.
It's like golf ball.
It's
Okay. Alright, we will get to this.
You're missing an L.
Daughter, father.
This is composite functions, and I think Mr. Lavick said that might have been one thing school had annihilated in your work last year. But this is not too bad in terms of that, but usually you've at least seen it, but I just wanted to double check for that. We'll get to that here in a minute. First thing here is to the top right. Okay, all those are listed out. Now, this is different notation. Okay, this is not the same. This is not the same thing. This just says, this is adding, subtracting, multiplying, dividing functions, just the notation for that. So you basically take your two and you add them together. You subtract them, you multiply them, you divide them. Okay? For that one's over there on the left, write small. I didn't do you justice. I didn't leave you quite enough room. So write a little small here today, sorry. But for those first ones, we got the same two functions. And so if you just see f plus g, then you just need to make this f of x plus g of x. Just add them together. Okay, take your two functions, and it's going to be 3x minus 4 plus 2x squared plus 5x. And when I am done, 2x squared, 3x plus 5x is 8x minus 4. Sometimes you'll see it as it was described as, f plus g and then x. You don't need to factor it. You don't need to do anything else. It's just 2x squared plus 8x minus 4. All right, the b is right next to that, beside it. Okay, f minus g, same thing, f of x minus g of x. And that is going to be 3x minus 4 minus 2x squared plus 5x. You do need to distribute that minus sign. Okay, to both of those, I'm just going to kind of do that and then combine like terms all in one step. So I get negative 2x squared. Let's see, 3 minus 5 is negative 2x minus 4. So I got f minus g of x. Product, f times g. Okay, for c there, multiply them together. So this is going to be f of x times g of x. And what does that give me? That gives me 3x minus 4 2x squared plus 5x. Okay, FOIL it. Okay, FOIL it, combine like terms. And let's see, that gives me, 6x cubed plus 15x squared minus 8x squared minus 20x. And then f times g is 6x cubed plus 7x squared minus 20x. All right, let me do this here. All right, before we go any further, like all of these are going to ask you for the domain. And they want to know what is the domain. What is the domain of all three of those? All right, and sometimes it still takes a while to process domain. When you hear the word domain, what do you think? Sierra, John Hunter.
Like the X.
It's the x values, right? All right. What do we think? What takes a number out of the domain? Okay. What makes something not in the domain? All right, what do you think about that? Thomas, any ideas? Not right now? Anybody, Mason?
Maybe 0
0 where?
in the X.
Well, all right, would 0 be in this domain? Just curious, would 0, just your gut instinct, is 0 in the domain? Avery? Yes, because when you plug in 0 for this one here, I get an answer back of what? 0. That's a point. That's an ordered pair. That's fine. What can't we have? We've talked about this before. We can't have 0 in the denominator. And what can't we have underneath the square root? A negative. Do I have a denominator? Do I have a square root? So is there any x values that I can't use? No. So what's my domain of all three of those? All real numbers. Negative infinity to infinity. If you have a denominator, then you have an issue you have to look at, or if you have a radical. We don't have either. So don't make this one harder. You don't have, so what's the domain of the first one? All real numbers. The domain of the second answer? All real numbers. Now for the last one, f divided by g. We're going to have a division. That means we're going to have a denominator. And so that is going to be 3x minus 4. So it equals f of x over g of x. And it's 3x minus 4. What is it? 2x squared plus 5x? All right, so whenever you have this, like I said, don't worry about factoring or anything before, but when we have a division problem, yes, you do want to factor to see if something will cancel. And also, we want to see how our domain will be affected. Well, nothing much happens in the denominator, but there is something that does factor out. It does have a GCF of what? X. You can factor out the x. And then it's times 2x plus 5. All right, that is your f divided by g of x. Okay, that's our division. All right, I do want to list the domain for this one. So I only need to work, now since I have a denominator, what makes the denominator equal to 0? Okay. Well, if x equals 0, or if x equals, what's that going to give me? Negative 5 halves? Okay, so what is the domain? F over g. It's going to go have everything but those points. So it starts at negative infinity. What's the first point it comes to that is excluded? Negative 5 halves. So negative 5 over 2. Union. Negative 5 halves to 0. Union. 0 to infinity. All right. Make sense? Know when it asks you for the domain, how to do that. Okay. And then for the first three, don't make it complicated. You have no denominator. You have no radical. It's just all real numbers for those. All right. That next little piece there, f of x. You're given the equation. All right. Find f plus g of 5. Well, what do you think that means? Okay, Thomas? Plug in 5 for x. And here's what you're going to do. You're going to make it f of 5 plus g of 5. Plug it in for both of them. And that's it. And then we're going to add them together. So f of 5 is going to be 5 squared minus 6 times 5 plus 8. Plus g of 5 is 5 minus 2. All right, see what you get. Dominic, you can let me know. The graph.
I just put something in the like on my images so work for me.
There you go. Dominic, you got it?
Yeah, I got 6.
6 should be right. 25 minus 30 is negative 5 plus 8 is 3. 5 minus 2 is 3. 3 plus 3 is 6. Good. All right, so that's going to be that first one. All right, part B. F times G of negative 3. Okay, F times G of negative 3. And that is going to be F of negative 3 times G of negative 3. And so that is going to be negative 3 squared. And then, hold on here, minus 6 times negative 3 plus 8. So take that answer times G of negative 3, which is negative 3 minus 2. All right, see what you come up with. Riley, you can let me know what you get. No pressure. Or addition. Go ahead.
Oh, yeah.
I got a negative 175.
Negative 175, I would agree with that. That's going to give you 9 plus 18, which is 27, plus 8 is 35, times negative 5. Now, the biggest mistake I may see is a lot of people just multiply those two together. Make sure it's negative 3 minus 2, and we get negative 175. Wait for that one. All right, so F of 3 times G of 3. Now, that part C there, same two functions. I just rewrote them for my sake. X squared minus 6x plus 8, and G of x equals x minus 2. All right, find F divided by G and state its domain. Well, F divided by G all right, instinct, right at the top is F of x, the bottom is G of x, but you're not done because what do we need to do here? You got to factor the numerator to see if anything will cancel. You always have to do that when you have a division case. So factor x squared minus 6x plus 8. And let's see, that will factor into x minus 4 times x minus 2. What cancels? X minus 2's cancel. So now it simplifies to, hold on, x minus 4. All right, now be careful here on the domain. The domain is not all real numbers because you have to go back to the beginning. So when we first did this, what can't x equal? X can't equal 2. So it still can't equal 2 at this point because this is our very beginning. We had a division problem. And even though it canceled out, we still have to throw out the 2. So it's going to be negative infinity to 2 union 2 to infinity. Okay. All right, now composition of functions. Fog, if you want to call it that. You got to watch. It's not multiplication. It is not multiplication. It is an open dot. Okay. It's not f of x times g of x. What it means, as you see right there, is you apply the g function to x. You take g of x, then you take that answer and plug it into f of x. Okay, so there's really two things going on. Now this domain here is not going to make sense yet. We'll have to talk about it in a little bit. But for anything to work, it has to be, you can't make anything equal to 0. I can plug x into the g function, take that answer, plug it into the f function. All right, it's going to be easier to show you an example. Flip it over. Okay, make sure, do not put g of f of -5 in for part B. Put those both at the top. Okay, there's something different for part B. All right, f of g of 2. Okay, f of g of 2. Well, if you follow that definition, okay, it'll look like that. Okay, you follow that definition. Okay, we're not multiplying those two together. So f of g of 2 will look like this. All right, calculate g of 2. Plug 2 into the g function. Okay, you're not going to do anything new. Just apply it in a little slightly different manner. Plug 2 into the g function, which is going to be 4 times 2 squared plus 5, 21. Now, here's what you do. Basically says take the function f and then plug in whatever g of 2 is. Well, g of 2 came back to be what? 21. Plug that into the f function. So f of 21 is 3 times 21 minus 2. And what do I end up with? 61. So that means that f of g of 2 equals 61. Okay? All right, move over to the right there. Right small. G of f of -5. G of f of -5. So find out what f of -5 is. All right, if you think you know what you're doing, figure it out. If you're not sure, I'll go through it with you.
Of course. I thought that was the other problem on the board. So that's why I had this. I can rearrange this. You can fix it.
I know, I did do a good job. Yeah, you picked it.
That's already answered.
Yes, yeah, you're fine here.
I just put it in the
Okay. All right, there you go. Yep. All right. Thank you. All right, good. All right, 1161. 1161. So f of -5 is going to be 3 times -5 minus 2. -17. Take that. G of -17 becomes 4 times -17 squared plus 5. That's a big number. 289 times 4 and then plus 5 though. 1161. So G of f of -5 equals 1161. Okay? For that answer. All right, now that's just that top part. Hopefully you got a little bit of room here. This is the B part. Now it just says f of g of x. No number there. F of g of x, and then we're going to do to the right there, g of f of x. So. Alright, so however you need to spread it out, hopefully you can get it in up there. Alright, f of g of x. If we look at the definition, what are we going to do? Okay, what are we going to do? Well, if it said f of 2, you would take 2 and plug it in for x, right? So what do I do now? I take the entire g of x and plug it in for what? X. Take the entire g of x and plug it in for x in the f function. Okay? So it's going to look like this. Here's your f function. It is 3. Take the x out, put in 4x squared plus 5. But don't forget, you still have that minus 2. It is 3x minus 2. Distribute combine like terms. You're gonna get expression. You're not gonna get a constant. You're gonna get an expression. So now that gives me f of g of x. 3 times 4 is 12x squared. Plus 15 minus 2 is plus 13. So right there, that's it. Okay, I kind of did that last step together. Well, right above that, we did f of g of 2, right? And we got 61. Well, if I do f of g of x, and if I plug in a 2 here, it should give me the same answer. So 2 squared is 4. 4 times 12 is 48. And 48 plus 13 gives me 61. So there's 2 methods you can go about it. You can plug it in the first one, take that answer, plug it in the second one. Or you could find f of g of x and then substitute in. If they just give you a constant, I would still do it this way at the top. Okay. All right, what's g of f of x going to look like? All right, we're about out of time. So let me just at least set that up. G of f of x. Okay, my g function is going to be 4. The x gets replaced with 3x minus 2 quantity squared plus 5. Then what do we got to do with that? You got to FOIL. Combine like terms. All right. Here, let me do this. I'll freeze the other one. Where's it at? I'll freeze that over there. And just for my sake, I'm going to finish this. 9x squared minus 12x plus 4. And then that's what it would look like. Just so you see it. All right. There's that assignment. You guys have a great day. Thank you.
It's gonna be the same day tomorrow.
Not hard, it'll lie.
Bye, baby. Have a good day.
Amazing.